Here is the procedure maxHeapify. It has two parameters, the array A and the index at which we are checking if that is a maxheap or not, the index I. So of the index I, we will extract the left child and the right child as L and R. Left child of I, this left child of I will return to 2 into I, and right child of I will return 2 into I plus 1 as discussed earlier. And then if L is less than heap size and array at L is greater than the array at I. Okay, here we are checking a condition L is less than or equal to the heap size. As told earlier, heap size is the number of elements that are taking part in the heap building. Suppose here all the elements are taking part, that is 1 2 3 1 2 3 4 5 6 7 8 9 10 11 12. All the 12 elements are taking part, and here I have considered the node, this node. For this there is left child but there is no right child. Suppose for this there is no left or right child, so for this condition will be false. If L is less than the heap size is still 12, and here we will get around 13 and 14, 13 as the left child and 14 as the right child. Sorry, 13 14 and 15, 14 as the left child, 15 as the right child. So L is less than the heap size. I got 14, 14 is less than heap size 12. No, therefore we won't have to consider this node because we don't have any child nodes. So we always start from the nodes that are having at least one child. That is, from this node we have to consider. For here we don't have to check anything. That's why this condition is there. And okay, if it is less than the heap child, that is somewhere this node. For this node, its left child is less than the number of, means its index, whatever is its index, it is less than the heap size. Therefore we can continue checking whether at this index it is a max heap or not. So if L is less than the heap child, heap size of array A, and A of L, A at L is greater than A of I, that is if the left child is has greater value than the present index, then my largest is a variable that it stores the index of the largest element among the three elements, the ith element or its left and right children. So the largest will store L, because at Lth index it is having it is greater than the present node. Else largest is I, because if L is not greater then I is greater. Again we are checking for the right child. If R is less than the heap size, less than equal to heap size, the same explanation as I had done here, and the right child is greater than the largest value. If the largest is I or the largest is L by here before this thing, then it will compare. If R is larger than the largest thing value, then largest has the value R, because of let us consider example 81, 82, 83. Initially largest is not initialized to anything. So if L is less than heap size, we assume that L is less than heap size and R is less than the heap size. That is we consider all the three nodes. This is my I. So if A of L is greater than A of I, it means 82 is greater than 81. This condition is satisfied. Therefore largest is having the value now L. Had it been 80, largest would have considered the value I. Okay, so again we are checking if R is less than or equal to the heap size. 83 is less than equal to 8 this thing R is less than equal to heap size. Yes, of course, because we are assuming that. And A of R is greater than A of largest. Now largest is having the value L, that is this thing 82. So 83 is greater than 82. Yes. Therefore, now largest will have the value r. Had it been 80, it would have the value I, that is 81. 83 is greater than 81. Yes. Therefore, it will have the value r. So largest is r. There is no else, because we don't have left any other condition. And if this element is the largest, larger than these two values, then obviously we do not have to change anything, because in maxheap these all are the parent is greater than the children nodes. But if it is not equal, if the largest is not equal to I, then what we have to do, we have to swap the things. Here 83, here 81. We have to swap the largest value, whichever is the largest, the left or the right, with AI, with this value. And then again we have to check if at largest it is maxHeapify or not. Whatever we were doing it here, we were checking for this thing, and then we were seeing the 73, and here we were going from bottom to top. But here, since we are doing this recursion, we are going from top to bottom. Okay, now and then the procedure ends. So with this example, let us see this function. I am assuming my I is 3 here, this node 66. What is my array? My array is 88, 77, 66, 2, 1, 99, 54, 22, 11, 80, 0, minus 1, 100, 81, 79. This is my initial array. So now L is left child of I, that is, this is L, this is R. L equal to 6, R equal to 7. If L is less than the heap size, now what is my heap size here? If I am considering this as my, this is my index, and my heap size is the whole array. In further videos of heap sort, we will see when we have to change the heap size. So here this whole thing is my heap size, that is 15 is my heap size. L is less than 15, yes, and A of L is greater than A of I, means left child is greater than right child, yes. Then largest is L. In largest we have here L, that is 6. Else part is not executed. Then again, if R is less than equal to heap size, yes, 7 is less than 15, and A of R is greater than A largest. A of R 54 is greater than A of largest. A of 699, no, condition is not satisfied. Largest remains as L, that is 6. Yes, among these three elements 99 is the largest, which is at index 6. If largest is not equal to I, no, largest is not equal to I, swap these two, means largest with I. So this is my 66, this is my 99. Then maxHeapify A and the largest, this thing here. Earlier we were going from bottom to top. Here we were checking previously manually, but in the programming, due to recursion, we are going from top to bottom. 66 was the 6 index was my largest. Now I have to check maxHeapify here. Array thing is same. Largest is now I is equal to 6. Left child, right child, 12 and 13. Then if L is less than heap size, yes, 12 is less than 15, and A of L is greater than A of I. Minus 1 is greater than 66, no. So largest is I. This thing is, means index 6 is again largest. If R is less than heap size, yes, 13 is less than 15, and A of R is greater than largest, 600, here it is 100. Yes, this condition, both the conditions are satisfied, therefore largest equals to R, that is 13. It is now 13. Now what? Largest is equal not equal to I. Yes, 13 is not equal to 6. Therefore, swap it. This will be my 100. This will be my 66. Again, maxHeapify A of largest and 66. We go. This is my largest. So this 13 is my now index I. Left child, right child. This condition won't be satisfied. This condition won't be satisfied because its left child and right child will be around 26 and 27, which is not less than or equal to 15. Therefore, these conditions are not satisfied. This condition is also not satisfied because largest is equal to I. Since here else part was executed, this not satisfied, else part is executed. Therefore, largest is equal to I. This part won't be executed and it comes to an end. So we are left with 88, 88, 77, then 99, then 2, 1, 100, and so on. That does not matter now because it is not sorted, and when we will complete the heap sort, then only it will be sorted. So at worst case, maxHeapify might travel all the tree down. Maybe this is my I and I have to travel till the bottom of the tree due to this maxHeapify recursive call. So this traversal will be of height h. This traversal will be of height h. So my time complexity is big O of h, but we already know that big O is log n base 2, or we can ignore base 2, it is order of log n. This is the time complexity in the worst case for the maxHeapify function. For n elements, for a heap having n elements, if you represent the heap using an array, the leaf nodes of the tree will be present at indices n by 2 plus 1, n by 2 plus 2, and so on. It is telling if we have here 10 elements, then the leaf nodes start from total elements by 2 floor of it plus 1 and so on up to n index. So here 10 by 2 plus 10 by 2 5 plus 1 6. From 6 to 10th index we will have here leaf elements, which is true. So this was just a fact.